Hello, everyone. Uh, in this session, we have presenters from almost around 5 countries: Russia, Indonesia, Italy, India, Greece, and United Kingdom. So good morning and good afternoon to everyone on behalf of myself, Mihir Chauhan, and my colleague Richa Sarma from Team World S4. We welcome you to the technical session 4C of Fourth World Conference on Smart Trends in System, Security, and Sustainability World S4 2020. Due to COVID-19, we all are going through a new normal phase, and the team of World S4 wishes you a safe and healthy time for you and your well-wishers. We are constantly trying to overcome the challenges that research community is facing at different level. We at Global Knowledge Research Foundation are fully committed to contribute and enhance the digital experience in research activities. To continue further, this conference has received tremendous number of submission, which has crossed more than 700 plus numbers from 40 plus countries through direct submission as well as special session. Out of that, 142 papers were accepted by the technical review committee. So once again, we all would like to congratulate you for your research work and to be a part of the success story of fourth version of World S4 2020. Further, I like to invite our session chair, Dr. Mahesh Bundele. Hello, sir. We welcome you on behalf of World S4 2020.
Yeah, hello.
Uh,
Good
yes.
morning, everyone.
Yes, good morning, sir.
Yeah,
So Dr. Mahesh Bundele is currently Principal and Director of Purnima College of Engineering, Jaipur. His area of research interests are wearable and pervasive computing, artificial intelligence, smart grids, microgrids. He has organized and chaired many IEEE, ACM, Elsewhere, and Springer international conferences and workshops. And he has delivered keynote addresses and he has more than 100 publications to his credit. So thank you very much, sir, for uh, joining as a session chair. So I would like to share few things to all the presenters. At the time of presentation, we will unmute you and we will give the right so you can share your presentation. Uh, so 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 now, yes, Dr. Mahesh Bundel, we move ahead with our technical session. So we have with us our first presenter, uh, Vladimir, uh, and he will present a paper on developing a smart cyber physical system based on digital twins of plants. Yes, Vladimir, now you can share your presentation.
Yes, I can share the screen. Yes, greetings to everyone.
Yes, please.
Okay, so very nice to meet you. My name is
Thank
Vladimir
you.
Laruhin. Yes, Professor Peter Skoblev was expected to show you the presentation, but some occasions, there are lots of them. So I can also share you our results of developing a cyber physical system with the state-of-the-art digital twin of plant. So you see the presentation, am I right?
Yes, we can see your presentation.
Okay, so I'm going. Uh, Smart cyber physical system could be implemented to modern farms in case of the system could contain feasible ways to interact and connect different smart machinery, data collection and analysis, for example, from sensors or remote sensing, to run the employees and manage the pesticides and fertilizers. Cyber physical system should also allow decision-making support, and knowledge bases and ontologies could be used for the purpose. The main difficulties of decision making in modern agriculture is that traditional methods of plant growth process Mhm. Sometimes could be not relevant because of global climate change. Since 100 years experience models doesn't work at high turbulent today conditions. So the challenge of developing our smart cyber physical system is to pursue these two goals: interoperability and wide functionality of machinery and vehicles, and to make an adequate decision-making service. Ah, well, I can do just now. So, a valid and robust approach to adequate decision-making could be a digital twin of plant, as we think. It should be able to imitate the life cycle and synchronize with the living plant on the field to make the recommendations and decisions in cyber physical system based on environmental information. For example, temperature, participation, humidity, and so on. Such a complex and uncertain system as a plant on the field is also hard to predict using meta-heuristic model based on long-term training process. So we have chosen an approach of multi-agent technologies based on knowledge bases. As I've told earlier, digital twin of plant would be a decision-making service for cyber-physical system, which will define date and scope of necessary field operations based on plant growth stage and condition. Cyber-physical system inputs data from the field sensors and, for example, agronomist inspections, simulates the real parameters based on input data, and then controls digital twin input data. Accordingly to the comparison between plant and fact parameters, digital twin of plant can adjust the growth plan and then proceed the changes of growth to cyber physical system. Knowledge base could also learn new knowledge while system operation. This cyber physical system architecture suppose multiple smart services which could be developed by third-party developers as well and widen their functionality of the system. The main models of cyber physical system are described here. They include knowledge base, multi-agent digital twin, multi-agent adaptive planning for artificial intelligence, and a number of workspaces for various applications for different employee roles in the farm. Development of knowledge base for plant production includes the following steps. At first, we need to create an ontology of plant development, describing the classes of basic concepts and relations between them for the plant growth process. Then ontology describes the main controlled and uncontrolled factors affecting plant and yield. Climate factors such as air, temperature, participation, radiation, such as soil, for example, microelements, nitrogen, phosphorus, and so on. Crop species, agricultural measures such as matrix of predecessors, soil cultivation technology, for example, protection products from fertilizers, pesticides, and so on. Plant structure such as grain, root, stem, spike, and so on. Then a state graph of each crop species is built based on ontology, which is used by an explanatory technology. Excuse me. My fault, I hear, excuse me. Ontology and descriptions of state graphs of different plant varieties form a public free knowledge base for the plants processed in the farm or every region. Each farm or agronomist from the farm can adjust the public free state graph and create its own modified state graph, who is motivated to fill the knowledge base with the royalties. Here's a part of knowledge base for crop production is shown. It can contain growth stages and micro stages, resource consumption, vulnerable and optimal climate parameters, and so on. Each piece of information, such as problems in the fields, limbs of plants, climate and supply requirements, are specific for each growth stage and each plant. So this is why we observe an ontological spider in the state graph. So state graph of a crop growth stage could be as follows. Each growth stage has the initial state, input and output values. Analysis of necessary events and conditions, such as heat, humidity, agricultural operations, track digital twin in planning the duration of current growth stage, predicting the next stage, and estimating the potential yield. Each event has bonuses and penalties for both duration and yield plan. In our developed and patented ontology constructor, we have filled a knowledge base for crop production. Semantic web could be observed from the left, and from the right, a page of entity. Here we have shown wheat, spice is shown. This constructor allows to easily view and modify the knowledge base. No special skills are needed. For example, it could be easily used by agronomists to collect new observed facts in the fields. We use multi-agent technologies to solve the tasks of precise farming. When having a common sense about the whole field crop isn't enough, we need to associate an agent to each crop in the field and divide the field to multiple parts, or even each plant, providing own agent for each other. This approach helps us to simulate real state condition. When each plant contacts with his neighbors for the microelements from the soil, for the pests invasion, for example, agricultural events, and so on. Going deeper, each plant could be divided to the plant limbs, and all of them can also be associated with the agents. Plant agents should be capable of finding a suitable state graph in the knowledge base and downloading it, generating agents for each state, which will be interconnected through consequence relation, interacting with the agents, of employees, of agronomists and machinery, soil and others, re-evaluating and forecasting the possible yield risks, risks of losing the yield in case of significant events, modifying themselves as well as deleting themselves, and sending all information about plant development to the knowledge base. A client of digital twin has already been developed to show the principle, as you can see on the slide. It includes knowledge base for wheat now, and for other crops like rice and quinoa, we are already developing. From the left, you can see a model of wheat growth stages. This semantic web describes some of wheat parameters and their intervals, which affect wheat growth process. From the right, you can see weather service collecting climate data from sensors and meteorological station, and could be inserted manually also. On the bottom, a Gantt chart is of growth plan for the plant agents is shown. It shows different growth plans with different dates and durations, which, because they illustrate wheat in the two fields from different regions of Russia. Digital twin of plant will also ask the agronomist to inspect the crop in the field and to check whether simulated growth plan is valid or not. A mobile application was developed for this purpose. It has some functionality of cyber-physical system and gives agronomists a way to inspect the crops and manage the field operations with just only one smartphone directly in the field. So in the paper, we have described an approach of digital twin of plant implemented as a decision-making service at smart cyber-physical system. Digital twin of plant helps to plan crop production and improve the yield. Multi-agent technology shows a great advantage to reach the goal of digital twin of plant, and the prototype of multi-agent digital twin was already developed for wheat. We see this direction to be very perspective, as digital twin of plant meets various applications. It can help improving the quality of yield and reducing resource consumption. It can be used in precise farming, in growing specialized crops, in plant laboratories, and so on. The research was supported by Russian Ministry of Higher Education and Science. So I'm here Professor Skobelev is our technical supervisors. I'm Vladimir Skobelev. We'll be happy to answer your questions. Thank you.
Yeah. Participants, if anybody wants to ask any question on this.
Uh, yes, sir. Do you have any question, Mahesh sir?
Yeah, I'll ask. Let
Yeah.
if participant want to. Nobody there? Yeah.
Actually, they are mute. If anyone has any question with Vladimir, you can put into the chat. I will ask on behalf of you. Uh,
Nobody.
yes.
Okay. Yeah. Yeah. Can you tell me? You have just presented a conceptual paper. Is it right, Vladimir?
No, we already have a prototype of our cyber physical system, and it is implemented in some pilot farms in Russia.
So you have done something practically, some sensory data you have collected?
Yes. So we have a pilot farm, and we have a lot of meteorological data, and we have a lot of data related from the fields about the crops they are growing, about the yields they are getting, so about the machinery we have. So we have a big industrial pilot farm, and we implementing this system there. It's a kind of 30,000 hectares of wheat production.
What kind of sensors you have put in the farm?
It is some iMetos meteor stations. iMetos has it is a big station. It has up to maybe 10 sensors in the fields for each field.
So
And
still you are in planning stage. You are going to set up a pilot project.
What?
You are going to set up a pilot study project.
So
you have not done it.
We already implemented in the pilot farm.
So can you just tell me when the seed is under the ground and in growing stage, what kind of parameters would be required to be measured?
Now our meteor stations can measure all the parameters like humidity of soil, like the duration of sun radiation and the value of sun radiation also. But for our digital twin of plant, right now we're using only temperature and humidity of air and soil and the soil content, which how many microelements do we have, like potassium, like phosphorus, nitrogen, and so on. A lot of other parameters right now we are not including, but the ontology can be
correctly
wider.
Yeah. Okay, thank you.
Okay. Yes, thank you, Vladimir.
Thank you.
Yeah, so we move ahead towards our next presentation. So I'd like to invite Elia Oronzo Marasco to present a paper on Authentican, a protocol for improved security over CAN.
Okay.
Yes, now you can share a presentation.
Okay, I'll share the screen. Okay, can you see it?
Yes, we can see.
Okay, good morning. I'm Elia Alonso Marasco, and I'm talking about Authentican, a protocol for improved security over CAN. CAN network is one of the most used network in vehicles, specifically in cars. There are many others, but CAN is the most important. And when we talk about security, we talk about these 5 points. Availability is when data must be available during the transmission after that. So the receiver node can read the message. Confidentiality is when a subset of equals that are electronic control units can read specific messages that are encrypted. Integrity is when data cannot be modified during the transmission, and the receiver can agree for the message or discard it if it said it is modified. End-to-end encryption is when only the sender and the receiver can read the message and the other echoes can't read it. And the spoof detection is when an echo or a node can detect malicious nodes that are in the network and can replicate message. There are several approaches to design security about CAN. I'll cite something that. The first is Authentican that use CAN Plus to extend the payload's size to implement a secure broadcast using authentication based on hashing protocols. Vatican is another authentication system based on CAN, but is also backward compatible. So it uses standard payload size. Token is another authentication system based on CAN that use AES, symmetrical cifration, and Chasky hashing algorithm. And another one use CAN-FD protocol. I say CAN-FD because CAN-FD is different from CAN, standard CAN, because use a larger payload size. But this CAN-FD sec use a gateway echo to deliver session key. We propose Authentican to provide encryption and authentication from CAN network. It is based on CAN-FD because we need 74-byte payload on packets. This protocol is based on two distinct phases, the startup and the operating phase. The startup is based on the broadcast of public keys, the broadcast of encrypted nonces list, and the synchronized nonces list. The first step, the broadcast public keys, is when one node shared to each other nodes is its public key. And with this public key, other nodes encrypted the nonces list. We implement nonces list to provide more entropy to packets with the same payloads. So there are four states on these payloads. The first 2 bits is the state, and the rest of payloads is used to push data. The state 00 is for broadcasting public key. The state 01 is used to send non-set list, which is encrypted with the receiver public key. The state 10 is to send message, the encrypted message, which is concatenated with the first non-set in the list. And the state 11 is used to synchronize the non-set list when all nonce are terminated. We are simulated this protocol using a multi-thread simulator, and in this graphic we see the time occurs to to simulate the encryption of message. So as much are nodes in the network, much is the simulation time. We see that is strictly proportional in this graphic. The second simulation is the number of message as much as the nodes in the Authentican. So we see that we started the simulation with the 5 message up to 30 message, and we see the simulation time is uh, is going up. Uh, I have to specify the different from the boot and the semi-boot in Authentican. In the boot, we have the full boot as we find the broadcast of public keys and the broadcast of all non-set list. In the boot semi-active, we find only the broadcast of public keys, but the non-set list is sent only when a node wants to communicate to another. So we see that communication time is uh, is is not very much. So this protocol guarantee confidentiality and authentication from CAN-FD protocol. And we use this simulation to evaluate performance and latency between this protocol and the standard CAN-FD standard. Thank you for your attention.
Okay. Participants, anybody want to ask any question? Can put it in the chat box. Okay. Let me ask something. You are talking about authentication protocol, isn't it?
Yeah.
Yeah. So CAN-FD, how does CAN-FD work? What have you done in that to make it authenticate?
We started from CAN-FD because we need a larger protocol to put in the public key, because when we use asymmetric protocols for encryption, we need a larger packet to put the key. So the start is CAN-FD, but we put in encryption and authentication protocols.
Okay. So you have done encryption also using how did you encrypt it?
Now we only started from the simulation. We have after to develop it with specific ECUs, hardware ECUs. So we don't.
Simulation time is not the specific parameter which can give you the indication of performance of your protocol.
Okay, we specify a simulation time which is the time to craft and encrypt using using standard times of encryption protocols.
Okay, I think you need to go in depth of the protocol. In your presentation, you are not shown any flowchart or any kind of algorithm, any kind of modification in terms of your contribution. You need to look into that, and more precisely the experimental scenarios. You have considered only 5 messages transmitted over that, and then simulation time is measured. Thank you.
Thank you.
Yeah, over to Mir.
Yes, thank you, sir, and thanks to Aliyah. So we move ahead towards our next presentation. It will be by Zakia Malik. She has some unseen circumstances, so she will present now, and after that, there will be presentation of Kristalina and Prasant. So yes, Shakia, you can set your presentation now.
Okay, sir.
She will present a paper on user behavior pattern, signature based intrusion detection.
Good morning, everyone. Sir, am I audible?
Yes.
Yeah, yeah.
Okay, sir. So, good morning, Mr. Mihir Chauhan. Thank you for inviting me. And good morning, our session share. Sir, actually, I am in a village of some India, so there is an internet connectivity as well. Fine. So it might happen during the presentation. You face some problem that maybe I'm disconnected or something like that. So I'm sorry for that. Okay.
Okay.
So basically, I'm going to talk about my research paper on user behavior pattern signature based intrusion detection. Let me start with, okay. So before going to what I work, let me preface one base for what is IDS. See, the meaning of intrusion is that it is a thoughtful, unauthorized attempt, successful or not, to break into access and manipulate or misuse some valuable property, which is harm. The result is in the harm the system. And the person and the attacker who did this, that is known as a intruder. And that intruder could be a software or a person or a hardware device where the software is installed. Fine. Now from the figure you can see that the intrusion detection system is divided in two parts: anomaly based and misuse, which is a signature based. In this paper I've worked on a signature based. So what is a signature based? See, as we know, the meaning of signature is nothing but the pattern. So it is basically work on previously known patterns. Fine. And this detection concept assume that each intrusive activity or pattern is described by some signature. Fine. Hence the variation could be it's considered as a new attack or new signature. So that is comes into the anomaly based. Fine. The anomaly based intrusion detection compares the current activity with some stored activity of let's say I have given you the from the diagram you can see that anomaly based intrusion detection can be categorized as a behavior based and traffic based. On behavior based, it is categorized as system, user, and network. That means it is stored some activity of system in a profile and then map with the current activity. So this is a comparison between the stored activity and the current activity. So that is this system, user, and that is anomaly based. Now the idea is also classified in two ways. One is host based intrusion detection and network based. In case of host based, the idea is installed on a host, or it is monitors the data whatever going on the host in host. So my research paper and whatever the implementation I did, I work on host based intrusion detection system. And the talking about the network, it is on a network, it will monitor the network traffic. And whenever if intruder is sniffing, so it will identify it is intrusion or not. So I am focusing on host based intrusion detection system. Now whenever so what is the outcome of IDS? Fine. IDS will generate four types of alert: false positive, false negative, true positive, true negative. Fine. The goal of any IDS is to minimize your false alarm. Fine. So what is a false alarm? False alarm, in false negative, the IDS represent the number of intrusions as a normal, and false positive, it represent number of activities as intrusive, the normal activities as a intrusive activity. Fine. So our goal, our research goal is to minimize the false alarm. So system will give you 100% accurate result. Okay. Next is what is BIDS. BIDS is nothing but
Your voice is not clear,
a
Jakia.
behavior based intrusion. It is observing deviation from non-expected behavior. Now it is audible, sir.
Yeah, yeah. Now
Hello,
it's yeah, yeah.
hello.
Now it's okay.
Yeah, okay, okay, yeah, okay, sir. Yeah, fine. Okay. So, see, what is BIDS? BIDS nothing but it is observing a deviation from normal or expected behavior of users. Fine. The expected behavior, that what is expected behavior? So, expected behavior would be prepared by the previous and history of that user working. Fine. And it is also provide automatically discovery of this attacks. But the problem with this BIDS is that it is always generate high false alarm. Fine. So still the research is going on to reduce this false alarm. Fine. So how to proceed with this? So to proceed with this, first you have to prepare a behavior profile. So what is the user behavior profile? Behavior profile is nothing but the process of capturing, defining acceptable user behavior. Fine. This is the flow chart of my system. This is just it is not the architecture. This is just tell you the flow of the system. You can see there is a user activity log, whatever the user working, because it's a host base, and there is a rule engine where rules, all different rules are stored. These rules are provided by some experts. They are matching the current activity log with the stored rules and check if it is and see the rule file contain both the rules. I have created authorized rule as well as the unauthorized. So it will compare with that. Based on authorized, unauthorized, it will be generate an alert. And if it is not there, if it is not match over that, then it will update user profile and the algorithm will stop. Moving to the next slide, see, for implementation this model, I have to do three things. First, I have to find out how to get the log. Fine. So for that, I have created on a Linux operating system, I have created my own program, which is written in a Java, which will capture user activity. In a next slide, these are the parameter of user activities. Okay. In previous researchers had work on user profile. So what they did, they just consider, some of them are considered keyboard movement, some of them are considered mouse movement, some of them on right hand side the application related data. But in my research, I combined all this. I have combined the keyboard, mouse, as well as the other application specific characteristics. So based on this parameters, my logger will capture the user log and stored in a my system. Fine. So this is here you can see that my user profile is created. Now how my engine will work. Fine. So from this system, see, there is a problem because it is, I have created a user specific. So I my system need an administrator and an expert who provide the rules related to the system. Fine. So system, the expert will give rule to this my engine. Here I get the users data. Now my users current activity will match with the predefined rules. If based on that unauthorized and authorized, the system will generate an alarm. Here I have used a rule based engine system, that is JES. Fine. Otherwise it's normal if else statement. Okay, these are the some sample code of JS rule based where I've implemented. You can see I have written all these rules. I have written, see sir, there is a difference. I have written authorized rule as well as unauthorized, both the kind of rules written. Almost 1,000 plus rules could be written in that rule engine. Fine. And after writing the rules, I have defined some cases. So these are the 16 cases. For example, case one is it's check a valid record with fields with all valid data. Fine, I have stored this username with this name with this ID, and this is the time of logging, like that way. Case two, that is change username with increased process counter. Fine. Okay, so these are the 16 cases given in the slides. After this, this is my result. Fine. Sir, you can see the result. Actually, this I have done for user group. I'm a faculty of MCA college. So I have a student group, and in my intranet, I have to give them some permission. So based on their permission, I have created one rule engine. And that is given by the administration, that student cannot access this folder, student cannot log in after 6:30, student can log in before 6 o'clock, so that kind of restrictions. Fine. So based on that, I have created this case. Now in this result, you can see this is my actual result for a user group. In case one, the actual result is authorized, but in just present, it is again give you authorized result. Okay. Now see, this is a statistical mean and regression. This two I have already implemented in my previous paper. Fine. That my previous paper is again on user behavior based ideas, but they are working on a statistical method. So this is the result of statistical method. Now the problem with this statistical, sir, you can see this is a confusion matrix. Now the problem with the statistical method is that in case of mean, I don't get result. Fine. It is actual result that should be 9 case, it should be authorized, but it is give me a wrong result. That means high false alarm. It will give me, in place of 9, it will give me 8 unauthorized. Fine. So I move to the logistic regression. In logistic regression, again for authorized user, it will give me a proper answer. All authorized user, it will consider as a authorized user. But in case of unauthorized user, I won't get any result. It consider all. That means in logistic regression, all the user consider as authorized. So this is a problem of my last research, last paper. So I thought that, can I divide that, if some of if I go for some signature based combination, then what will happen? Then I implemented this rule based system. So from the rule based system, my result is improves. You can see here, it is authorized 5. In that, only one it considered as unauthorized. That means I got 4. But in case of unauthorized, accurate result. Fine. So in case of unauthorized, I get accurate result. You can see in yellow color. Fine. In authorized, I'm not getting the proper answer. When unauthorized, I'm getting proper answer, which is not I'm getting in logistic regression. Fine. So based on this, I've found that this is my conclusion side. I found that rule based system is still not giving me the 100% result. Fine. So our proposed pattern based on a technique works well with identifying unauthorized user, but it is not identify authorized user. So what my current research is going on now, I'm combining this logistic regression and rule based system with the machine learning, and I'm working on a 3-layer implementation. That means whenever the user log come, user profile is developed, first it will goes to the statistical layer, then it will go to the my this rule based, and after that it is going into the machine learning techniques. So this is way it will go to, and we are trying to reach to up to 90% uh, result of this. So thank you for this.
Yes. Participant,
Yes,
any
sir.
question? If you have any question, you can put it in the chat box. Okay. Zakia, actually, the work you have presented is very preliminary work, and you would have worked on machine learning approach. Actually, there are because a lot of work has been done on
Yes.
behavioral approach also, and integrating system. So there are lot many solutions given also. You have not given any reference which you have taken
Uh,
as a literature review part, and
okay, sir.
moreover the data you have collected from
Hmm.
your students only. That is also the different cases you considered. So very restricted, very narrow design is there. It
Hmm.
should have been
Okay, sir.
very even the database data sets are available. If you go to the site data banks, there are data sets given, and you can use those data sets, and then you can apply some because rule based approach is very old.
Okay, yes, sir.
When
Hmm.
we were using a expert system kind of thing, now it is the era of machine learning and deep learning.
Yeah, sir. In
Yeah,
my next
so
level, I combined, excuse me, sir. My next level, currently I'm combining all this with machine learning. I'm applying neural network with this.
but we
And
don't have
I have,
proper data set.
So for the data set, I have given to three private organization. Generally, they don't want to share that data. Actually, I want to work with real life data. So they won't allow me because the security issue. It will take my keylogger data as well. So because of that password and security reason, nobody ready to give me that data. That is why I take the permission of my director and take it my our organization, my students' status, faculty's
No,
data.
first you work on the data sets available on the net, and then you go for some real time data whosoever provides you.
Okay. Sir, I didn't mention that paper here. Actually, I have used KDD Cup data set before
Yeah,
or in previous paper.
yeah.
So
So
that after I thought that I have to work on a real life data. I'm trying to search and looking for the real data, but nobody ready to give me, sir.
no, no, real data also you have to give a full thought to create it.
Mm-hmm.
What different kind of behavioral pattern can be there from the user point of view or from the hacker point of view, and then
Yes,
only
sir.
you can include all those cases and the data.
Yes, sir. Yes, sir.
So, so,
Okay, sir.
so
I'll
thank,
definitely follow your suggestions and improve my research. Thank you for
okay,
suggestion.
thank you.
And sir, if in case anything I need, I've seen your profile, so I can talk to you. I can
Yeah,
share
yeah, yeah,
my
yeah.
definitely,
Thank
sir.
you,
Thank you so much, sir.
thank
Thank
you.
you so much.
Okay, thank you, Zakia.
Thank you, Mihir.
So if anyone has any question with Zakia, you can share into the chat, or you can exchange email addresses as well for the future communication if you wish. So we move ahead with our next presentation. It will be by Prasant. He will present a paper on IoT-based framework for smart campus, COVID-19 readiness. Yes, Prasant.
Yeah, hi. Are you able to hear me?
Yes. Hi.
Yeah. Hi, good morning, everybody. And good afternoon, based on the location you are in. Let me just share my screen. I'm just trying to do that. Let me know once you are able to see my screen.
Yes, we can see your screen. Please go ahead.
Okay, thank you. Okay, so hi, everybody. This is Prashant here. I am a senior client solution manager with Infosys. And this paper has been co-authored by Mr. Ravi and Pooja. So the topic of this paper is IoT-based framework for the smart campus, the COVID-19 readiness. In this presentation, I'm going to cover about the overview and background of this problem, the proposed approach, uh, the IoT framework for the smart campus, and integrating the new use cases based on the business requirements, and the conclusion about it. So coming to the background of this paper, we are seeing the smart campuses are gaining more and more traction. There is a lot of focus which is happening globally and worldwide by most of the organizations which has the capability to implement the new technologies. And we have seen a lot of advancement in the new technologies which has happened in IoT, the artificial intelligence and machine learning. And they have turned from theory to the implementation which is taking place in most of these campuses and the implementations right now. So while IoT is in the initial incubation stage, maybe a couple of years back, but we are seeing the large level implementation which has started happening in the global campuses where they started seeing the operational efficiencies and the user experience which is increasing. The companies has a focus on the sustainability and increasing the employee experience, and they are leveraging these technologies at the maximum extent. Universities, they are one other the part of the, they have a large campuses, and they are making their campuses smart, where they are using them as a living lab and implementing those technologies, and their focus is on enhancing the student experience and bringing in the efficiencies in their campus and the value-based learning. The stadiums, the arenas, and a lot of other places which are having the large campuses, we are seeing the focus is on bringing in the efficiencies and the user experience around it. Coming to some of the examples, if we talk about most of these companies right now, which are having companies, universities, or any other places like now which have a large campuses, they are focusing on bringing the operational efficiency and the user experience. We talk about the hyperscalers like Google, Microsoft, Amazon, and all. So these are the ones like that which have a big, large data center and the workplaces, which is more around the LEED certified. They are energy efficient, and they are more having a sustainability focus. And the focus is on sourcing it from the renewable energy wherever possible. Infosys, one of the leading Indian service provider, they have one of the largest campuses in India, as well as you can say it worldwide. They have again a LEED certification, which is towards energy efficiency and implementing the IoT in a big way, and to bringing in the efficiencies, the operational efficiencies. And the example is in the last 11 years, they have bring down the per capita energy consumption by 55%. And 44% electricity consumption is coming from the renewable sources where these companies are investing. Taking an example of one of the leading universities, the Arizona State University, and they are leveraging the IoT and the next generation technologies for this campus implement and enhancing the user experience. And for the connected stadium, they have implemented various sensors, and where they have leveraged that data to enhance the fan access. So it is only a subset, but it is happening globally at the big level. Wherever there are large campuses, we are seeing a lot of traction. We are seeing a lot of optimizations, which is happening, bringing in the operational efficiency and the user experience. Now, the proposal which is over here is, it is about the 5-layered IoT framework, which is being implemented in the smart campuses, and how we can leverage this framework for the integration of the new use case in the sustainability. And most of the campuses focusing on being in the use of water. Centers, the large campuses, the cloud-based infrastructure. We are talking about the various building management systems, which can be a uniform building management system for one building, but when it comes to a large campus, they would have implemented the various building management system over the period of a time. Then we talk about, for the connectivity part, it's a unified communication system. We are talking about the smart parking, which is being automated now, and to bring in the user experiences. And we are talking about in the large campuses, how we can have the autonomous vehicles, which can do a transportation based on the the source and destination. And we are leveraging this by bringing in the different technologies and implementing in the right sensors and measuring the right parameters using those sensors. So it can be your occupancy, it can be your air quality, it can be your energy, or it can be your temperature. So there are the various sensors which are being implemented in the infrastructure, and we are capturing that data. Now, this is all done with the focus on the end user experience. Now, while we are capturing the data from the infrastructure, it is more about how do you bring in the user experience, the end user experience, which leverages this data which we are capturing and helping the users to work it more efficiently, which helps in increased productivity and enhanced experience. So while we talk about the cafeteria, the smart cafeteria, which can be done based on the data points what we have received, the health and wellness of the employees. We talked about in the large campuses, if you have to move from one building to another building, what is the the optimal path which you can get it on the map. When we are going to have a meetings, which is the meeting room the nearest possible which is available. And so that helps you in while enhancing the user experience, you are leveraging your infrastructure in a more efficient manner. This talks about the 5-layer IoT framework which you are talking about. Now going from the bottommost layer, it is the sensors and data acquisition, where you have the various sensors which are utilized, where you have implemented across the campus. It can be your camera, it can be your air quality sensor, it can be your temperature sensor, it can be related to a smart irrigation, the water usage. All those sensors has been like implemented in the campus. The second one is the compute and network infrastructure layer. So while we are capturing the data from these sensors, we are ingesting the data in this layer and running the edge analytics wherever it is needed, where you have the time flexibility which is less, you have to generate some kind of on spot alert, it's emergency kind of alert, or you send the data to the cloud or on the on premise data systems which is there, and it can use the various kind of the communication protocols which is there. The third layer is the platform and integration layer, where we are talking about the various use cases, the various kind of sensors. Now it can be a different kind of a building management system, or it can be different kind of a use cases. They all integrate and combine together in the platform and the integration layer. The fourth layer is the application layer, which is the one which focuses more on the user experience, while the bottom three layers focuses more on the data acquisition and generating the insights from the data. This layer is more about whatever insights we have generated, how we can convert it in the business use case and enhance the user experience. It is whether if you want to bring in the energy efficiency, or it can be a smart cafeteria, the smart parking. So these are the applications which are developed on top of the layers, whatever has been on the bottom layers, whatever data you have got to derive that user experience. The top layer is about the monitoring layer, where you have the command center and you can have a centralized monitoring of the campus, where you are making sure that all the implementations, whatever has been done, whether it's a monitoring of the systems, or it can be a monitoring of the users, or any kind of implementation which has happened, you are monitoring those implementations, and if there is any kind of a error or any preventive maintenance which needs to be done, or any kind of action which is required, can be taken care, and this is all facilitated by this command center. This slide talks about integrating the new use cases. So this 5-layer is more about the implementation of the smart campus, and it also facilitates using a 3-step methodology about how do we keep on integrating the new use cases whichever it is needed. Which is about a 3-step methodology. The first one is ideate, which is about generate the new idea. When you want to see there is a business requirement, and when we are implementing, so get the idea about the new, generate the new idea, and then you validate the idea, whether how much is the feasibility with respect to a current system, and how much time it will take to implement that idea, whether there are alternatives which are available or not. And there are some ideas which can be implemented, the current system supports it. If not, you may have to end up writing a middle layer which goes and generates a different kind of the connectors, and you are able to implement those systems using the validation. The third one is the implementation, which is about developing the proof of concept. Once you have validated the idea, developing the proof of concept and the solution, which is done for the campus. Now take an example of say COVID-19 here. In the COVID-19, now we know that when the employee is entering in the campus, we want to make sure the temperature of the employee is well within the range. So you would have implemented a camera on the gate, and this camera, this video and the image analytics can be performed at the edge analytics, and you can get the data once the user is entering. You can take a heat map out there, and then you can generate what is the temperature of the person, and if the temperature is more than the threshold, the alert can be generated and the preventive action can be taken. But once it's well within the range, the person comes in, it has been approved, and all the turnstile and everything has been activated, and the person enters the campus. Now this data goes in the compute and infra layer, where the edge analytics and the action is being taken. Now in the platform layer, it is integrated with the backend systems. Now this information is sent to the backend system. Now once the employee has entered and crossed this stage, now he wants to see what is the seat which has been allocated. Now given the dynamics of the COVID, you want to make sure there is a social distancing which is being followed. And it depends on the seat allocation will happen in the dynamic manner. The platform layer, it will take care of generating those seat allocation, based on the social distancing, the parameters, the user's proximity with respect to his work location, and the seat will be allocated in the backend. Now the application layer will have a mobile app. So once the user enters, he can have a mobile app and which has been provided by the organization. He can have a look at it. What is the seat which has been allocated to me? And that comes in the application layer. Now in the monitoring layer, it is the centralized command center, which is monitoring the whole campus. At any point of a time, they know how many people are there in the campus, what is the current status, and based on the various image and video analytics, what is the situation of the campus. So that can be monitored using the monitoring layer by the campus. So this will help in integrating the new use cases in the more resilient manner. To summarize, we are living in the digitally connected era where we are seeing there is a lot of advancement which is happening, and the real-time data is playing a very important role in making the campuses more resilient. And we are talking about how do we implement these new use cases which helps in operationalization of these campuses in the quicker way. And the 5-layered IoT framework and implementing the new use case and integration of the new use cases in this IoT framework is what has been proposed in this paper. Thank you.
Yes. Participants, any question? Okay. Yes, Mr. Prashant. I think you have presented just a brief concept about what you want to say, rather than any kind of work you have done. Have you done any kind of work in the smart campus area or some COVID-19 cases or data or something?
Yes. So this is something which has been implemented as a concept here, and but it has been implemented in the organization where I work. So here we are talking about the smart campuses, and this is something which is being implemented, and it has been implemented, and for the COVID-19 also this has been implemented.
You have implemented it?
Yes, that has been implemented in the campus. Yes.
Okay, so because you have not talked about the specific parameters, specific sensors, or any kind of architecture which has been implemented for a specific purpose, because it is a huge uh, uh, topic, you can say. Because smart campus will deal with thousands of different aspects and the typical task. So it will have a large data flowing from one place to other place, maybe at the second layer, as you said, computer networks, and all those data need to be processed. And then if you talk about it, because if you consider COVID-19, because COVID-19 readiness you have specified in the title, and you have just uh, told few things about COVID-19. What could be the this one? So I think the paper is very preliminary, very much preliminary concept, and does not give any depth. If you have to actually make it a research kind of paper, you should have gone to some extent to in depth of some of the issues. Okay, thank you.
Okay, thank you, sir. Thanks for your inputs, and thanks a lot.
Okay. Okay, thank you, Prasant. I think Alexander has a question for you, Prasant, in the chat. So yes, Alexander, you can put a question. Definitely Prasant will give the answer in the chat as well. So we just give a small quick reaction from the bottom of the Zoom bar or in your mobile, a quick reaction for all the presenter. So thank you, Prasant, for presenting a paper. Just a moment, Prasant. Alexander want to ask something. Yes, Alexander.
Okay, one question.
Yes, please.
Thank you very much for your reports. Can you tell me, have you done students survey? did you ask students if they like all of the idea? For example, you put the camera in every corner. Uh, do the students like this? Have you done the survey students for the say?
Sorry, Alexander, like no, your voice was not very clear. Can you please repeat your question?
Have you asked students if they like all of your ideas?
Uh-huh.
Have you? Did you ask students? Did they like that you put the camera in every corner, for example? And do you understand?
Okay, so see again, like now when we are talking about the camera, you're talking about whether the employees or the users are comfortable with the camera installations, if they are okay with that.
Yes, perfect, perfect.
Okay,
Perfect.
so see again, like now when we are talking about these cameras, it is about when you enter in the campus. Now for the general locations, now for the security parameters also, if you have a look at it, the common locations, which is about your pathways, which is about your gate, and that is where like no the camera installations, or in fact like no take an example, if you go to a malls or anywhere, in general locations, these cameras are implemented, and this camera will help you in like no measuring those. See, first example which I take was for COVID-19. As soon as you are entering the campus, right? Now you have a video camera when you are entering in the campus. This is generating the heat map to make sure your temperature is well within the range when you are entering in the campus. And that is a new requirement for COVID-19, right? Which was not the requirement earlier. And the employees who are entering in the campus, they do not seem to have any issues, at least like in our organization. They are okay with that implementation because it is in the common area. But yes, when you talk about like the specific places like your workplace monitoring and all, that is where you need to have the due diligence done based on the regulations which are there, whether you can do it or not. But when it comes to like the central locations like your cafeteria, your entrance, I think like that is implemented most widely across like I think multiple countries, unless like there is a specific country which prohibits, and you will have to like take the consultation. If there is any regulation which prohibits that, then you will have to take the use case in that manner.
Okay.
I hope that
Yes.
answers your question, Alexander.
Yeah. Yes, Alexander, yes.
Okay,
Yes.
thank you very much. I understood you. I understood. Very useful thing, very useful thing. But I don't know if the students like this.
Yes, yes, because in all the countries that is important, because of the privacy issues and they are ready or not. But yeah, the thing
Yes,
is
very interesting.
important.
Thank you very much.
Right.
Thank you.
Yes, yes. Thank you,
And
Alexander,
just,
and
just
thank
to
you,
add like
Prashant.
one more line, Alexander, what you're saying is right, because the user privacy law changes from country to country. And when you are implementing these use cases, you have to consider the law of the land when you are implementing those use cases. And that you have to consider while you're implementing that solution. So it's a very valid point. But again, like the implementation will change in the campuses based on the country and the law of the land.
Okay.
Okay, thank you very much.
Yeah.
Understood. Very useful thing. Thank you. Thank you.
Thank you.
Okay, thank you. So we move ahead with our next presentation. So I would like to invite Krisalina to present a paper on strategic corporate social responsibility, SCSR, systematic literature review. Yes.
Hello to everyone. I'm very glad to be a member of this conference and part of your company. I'm going to deactivate my camera now and share my screen. I'm going to present our study regarding the concept of strategic corporate social responsibility, henceforth strategic CSR. Our presentation consists of 5 parts, namely the introduction, the research methodology that we've followed, the tables, the results, and finally our conclusions. It was in the early 2000s when CSR was related to firm strategy and transformed from a merely philanthropic deed into a competitive tool. Strategic CSR is defined by the European Commission as the voluntary integration of social, ethical, and environmental concerns into the core strategy and business operations in order to maximize the creation of shared value for shareholders, other stakeholders, and society, and to prevent the possible adverse impacts of companies. Strategic CSR is a contextual concept, meaning that it is highly influenced by the environment in which the firm operates. Challenges brought about by the COVID-19 pandemic, shaping the new normal, spurred us to examine whether and how strategic CSR activities impact firm performance, especially during recessionary periods like the one that we experience. The systematic review methodology is applied in our study and comprises 3 parts: data collection, data inclusion, and data extraction. You can see some of the most helpful papers that we have found. We have included 3 different tables in our study. Table 1 refers to the data collection process and the data inclusion criteria. Appropriate studies were identified in Scopus database. As you can see, we used 2 search terms which correspond to the research questions, as well as several filters which both resulted in 36 articles. We then excluded 4 articles because they referred to the antecedents rather than the results of strategic CSR. Table 2 and Table 3 present an analysis based on research method, study objectives, research findings, and future research suggestions, respectively. According to the first pie graph, a qualitative survey was conducted in more than half of the studies, while a little less than a third of them explored theories regarding strategic CSR. As evident in the second circle chart, most of the studies used secondary data. From our research, we found a consensus about proactivity, centrality, commitment, specificity as being the main factors which distinguish strategic from non-strategic CSR activities. Effective strategic CSR communication inside and outside the firm is also considered important for what is called the triple win. That is the positive impact for the company, the stakeholders, and society at large. Companies in stigmatized industries, such as in gambling or alcohol-related sectors, can also exercise strategic CSR activities if the perceived benefits brought about to society outweighed the societal costs. One of the benefits of strategic CSR is the creation of shared value and broad trust-based relationship networks. Strategic CSR is also related to innovation, either in terms of increased innovativeness of employees, either in terms of, or in terms of technological innovation. The good reputation entailed also reduces capital costs and potential socio-political risks. During a recessionary period, strategic CSR activities are more likely to be maintained when compared to non-strategic ones, because of the fact that they are more structured and routinized. Moreover, they contribute to the company's reorganization and renewal. On the other hand, criticism focuses on CSR being an empty promise or a strategy for avoiding regulation, and sometimes leading to unfair competition via political connections, usually in more corrupted societies. CSR is also thought to cause higher costs for the company if not effectively combined with a corporate strategy. Last, strategic CSR is viewed as a chore unless both moral and economic benefits are evident. In conclusion, CSR and strategic CSR are a continuum rather than two distinct concepts. There is no clear picture of how strategic CSR is related to fair performance due to the contextuality of the concept. However, strategic CSR activities and the combination of strategic and non-strategic activities have proven more beneficially, not least during recessionary periods. Numerous risks as well as opportunities are involved in the new normal, which could also be referred to as the new possible. That is why we argue in our study that this is the time for organizations to reevaluate their strategic CSR approach, prioritize their initiatives, and better engage the needs of the public. And it is our responsibility as researchers to provide the theoretical and conceptual framework for the strategic CSR of the new era. Thank you for your attention. Stay safe and greetings from Greece.
Yes, Mr. Mahes. Do you have any question? Your mic is mute.
Yes. Kristina,
Yes.
you have presented a review paper.
Mm-hmm.
It's a review.
Yes, it is a literature review.
Okay. So have you planned to do some research in this area, or you are just
Yes, starting in September, we will try to actually construct our own survey about how different companies, both in Greece and abroad, will approach their strategy regarding their CSR activities.
what kind of different strategies you could find actually?
Excuse me, could you please?
What strategies you could find in the literature? What strategies you could find in
What
literature?
strategies?
Yeah.
Okay. So we're trying to see if a company is implementing activities that are both philanthropic, but at the same time they benefit the company itself if they align with the strategy itself. So as I said, CSR is a contextual concept. That means that each company, depending on its size, on the environment in which it operates, actually approaches and applies different kind of strategies. It depends on the company. That's why we want to research more.
Okay, thank you.
Thank you, sir. Thank you for your comment.
Yes, thank you, Krisalina. So if anyone has question with her, you can put into the chat. Okay, thank you. So we move ahead with our next presentation. So next presentation will be by Argya, and the paper title is Smart Home Equipment Control System with Raspberry Pi and Yocto. Yes, Argya, you can share your presentation.
Good morning. Is it visible?
Yes, it is visible.
Okay. Hi. Good morning and good afternoon and good evening to everyone. I am Aditya Viswas. Today I want to discuss about smart home equipment control system with Raspberry Pi and Yocto. Okay. Home equipment control system is become a very popular topic from last few years. People's using different hardware software combinations to make the system more fruitful in terms of resource usage and the user experience. This project is another contribution on the same field. research area, we used a small ARM-based full-fledged computer called Raspberry Pi as the main component in our system. We took the customized Linux distribution called Yocto as the operating system for the Raspberry Pi. As the operating system is customizable, so we removed all the features of a general purpose operating system except only those features that we need for our system. We also removed the desktop environment to make the system lighter weight. We added the functionality for our system on top of the OS to control the connected equipment from the anywhere of the world. System architecture. Here is the full system architecture of our system. The main system is of course the Yocto OS. A Qt based GUI application is running on the OS. This application can control the GPIO pin of the Raspberry Pi. For the limitation of GPIO pin, we integrated the IO extension concept in the system. AVR-based 8-bit microcontroller Atini88 is being used for this purpose. We use the I2C port for the Raspberry Pi to connect those microcontrollers. Those I2C ports are being controlled by the GUI app. We developed a web interface for our system. The control input come from the web interface as well as the GUI application. Those inputs are being processed by the Yocto and sent to the specific microcontroller. The physical push systems and the some LED switch are attached with the every microcontroller. Microcontroller take the input from the I2C bus and from the physical switches, then processed and finally sent to the LEDs. Here the push switches are representing the original switches which are installed in our home, and the LEDs are representing the equipment that we need to control. Okay, this is the full working diagram of Yocto. First, it copies or clone or fetch the source code from the upstream code or local provided code. Then it unpack the source code if needed. If any patches are available, then apply those patches on the source code, then configure the source code and check the dependencies. If all are okay, then the source code start to compile. After that, the compiled code become available for those packages used. This is called staging. Then the source code being installed in a temporary location and wait for the final packaging. After all the package installation, the packaging process start. In this process, all those installed packages zipped under an OS image file. From this image, we can boot the specific hardware like Raspberry Pi and all. So this is the Yocto build process. We took the basic Yocto restro called Poki. On top of Poki layer, we added the Meta OE or Meta Open Embedded layer to get the basic functionalities of an operating system. Then we added a main BSP layer called Meta Raspberry Pi layer. Then this Meta Raspberry Pi layer will help to make the image specific for the Raspberry Pi. As our GUI application is using the Qt framework, so we have to include the Meta Qt5 layer. On top of that, we added our own design layer called Meta iAlloy layer. And this layer is contain the main GUI binary as well as the dependency files. So this is the user registration page. So after successful boot, this OS start this Qt application, and the interface look like this. This is our registration page. For the first time, user need to provide the basic information to create user account and track the data. So this is the login page. After successful registration, user can log in from this page. The user email ID and the password. These only two things are needed for this page. Okay, this is the dashboard page. This dashboard page are being redirected after login. First time, most of the dashboard remain blank. User need to user need to add the room name, device name from the device manager interface. Some extra features that are most important for a complete system are also implemented with this system, like the virtual keyboard, application update, Wi-Fi control, etc. This is the web interface. Mm, this is a pretty same with the dashboard interface in the application, as this interface is hosted in the public domain, so user can use it from anywhere of the world. So this is the uh, actual hardware setup. The figure one is the full hardware setup of the system. For development purpose, we used only two Atene88 module with the 8 switch and 8 LED in each module. The module are connected via the I2C bus and with the Raspberry Pi. A small screen need to be configured or connected with this setup, but unfortunately that is not captured in this photo. In the figure 2, we are flashing the Atene88 microcontroller board with the help of Arduino Nano module. So finally, we come to the conclusion of this work. As we proposed to use the old physical switch as a part of our system, so it is provides the backward hardware compatibility. With this, our system helps to use to control this home equipment from anywhere of the world, if needed. But still there is some part in this project where we can improve the system. Here we use the Raspberry Pi as the main component, but it has some extra features like CSI port, DSI port, multi USB ports, and many more which are not going to use in this system. So this is a pure waste of resource, but if we can use the customized hardware also, then we can come with a more efficient and low power consumption system. We use the HTTP connections for the communication between the Raspberry Pi and the web interface. But if we can replace this protocol with the TCP, then the connection establishment and the closing time can be saved. So as a result, we can speed up the entire system. So and those are the references which I used for my research work. Do you have any question?
Yes, Aragya.
Yeah.
I think you have presented a project. You developed a good project, and the project is presented as a project, not as a research. The what kind of means you have data structure you have used, what kind of algorithm you have used, or control algorithm you have used, that is not clear. Actually, you have just explained what hardware components you have used, how you have used, how you have connected, how you have operated. That's all.
Yeah.
Can you give some focus on your control algorithm you have developed?
So let me show the. This is the main architecture. So basically, we used two communication protocol from the web to local. We used the HTTP, and from the local Raspberry Pi to the Arduino, we use the I2C protocols. So and these are only two protocol we used, and if the some data updated in the web GUI, then it come to the local Raspberry Pi, and then it processed and came to the Atene88 microcontroller. This is the main data flow diagram.
Okay. If any of the participants has any question, thank you.
Mihir sir, you are
So now we are going towards the closing of the session. So I request Mr. Amit for the closing remark.
Hi, good morning, one and all present for this fourth session of WS4 2020 and it's an amazing summer London time. So if you are in and around Europe, just enjoy the beauty of this place. It's really amazing. And regarding the session, my thanks are due to Professor Mahesh Budele from India, and who is the principal and director at Purnima College of Engineering, for his all efforts and his presence to chair this session at this particular current scenario and time. And I thank you for your sparing your valuable time in this your busy schedules, and hope that your association and your participation to our organization will be soon increasing in different collaborative forms. And I request Mr. Mihir to kindly share a token of appreciation for Dr. Mahesh Bundele as an appreciation from our organization side. And
Yes. Thank you, Amit.
this is for you, sir.
Yeah,
And
yeah.
you will receive it through email because this is new digital times. So
Yeah,
it's new
yeah,
digital.
yeah.
So
We are in new normal situation. So
yeah.
yeah.
And my thanks are also due to all the authors who have come and joined us digitally for this session and presented their valuable contribution. I assume that the cycle time for a whole conference or a whole paper submission to a paper publication is approximately 7 to 8 months. So I thank you all for waiting for a long time, and still I think it will take another 2 to 2.5 months under normal circumstances for a IEEE paper to get published. So I think many of the authors have already signed their e-copyrights. Who have not signed will be receiving them shortly. So thank you very much, and you will also receive your certificates and payment receipt as well as a thank you letter from our organization just after the session is over. So stay safe, and we hope to see you next year physically for World S4 2021. And also, I hope and personally believe that this COVID-19 will soon be a thing of past. So thank you very much, and stay happy and stay safe. Thank you.
And just a moment, Amit. We will take one group photograph, not a physical, but at least, if possible, everyone can start your video camera just for a minute. So just for a memory, we will take one snap. Yes, thank you.
Last. मालूम नहीं कैसा लग
Yes, we will wait for just one more minute. Yes, thank you, everyone. We will share video of this whole session as well as photograph with you on the mail. Thank you, everyone. Enjoy your time.
ऐसा ही अच्छा